Hello, everyone.
Hi, Tom. Great. So,
Hey.
welcome, and glad to have you join us here today. I will pass it off right on to you, and hopefully you're good with your screen set up, and you can dive right in.
Yeah. So actually, I'm not the one who is going to present. So we have John here.
Okay. So let me
yeah.
I understood that you were going to present, but
I'm like a co-host,
Co-host. All right. Well, then we'll have you on stage, co-hosting on stage. I think it all should be good. Just wait for the system to click over.
Hello.
John, there you are. Okay, so you were going to be presenting then. Okay, back and forth.
Yeah.
Tom said that he's going to be the co-host today, but you were going to be presenting on behalf of Secret Network. Is that correct?
That is correct. I should have let you know in advance.
Then welcome, thank you, and I will give you the floor, and you can take it away whenever you're ready.
Yeah, let me make sure I got my screen share ready real quick, and then we'll get started. I think I'll just do some basic information. Tom can help with more interesting questions that people may have.
Great.
Can you all see my screen? Perfect. Let me full screen that also. Present. All right. Hi everyone. We're with Secret Network, and we're very excited to be sponsoring a prize for 5,000 secrets in this hackathon. And I'm going to tell you today a bit about what we do and what kind of project submissions we're interested in for this hackathon. For those of you who may not be aware, at Secret Network, our primary goal is to drive adoption for decentralized technologies, and we're trying to reach this goal by focusing on privacy. We've realized over time that privacy has usability and advantages, and also just like opens new set of applications to be built on decentralized systems, and we achieve this by presenting the concept of a secret contract, which is like a smart contract but with encrypted inputs. And what's interesting is today we're going to talk about two ideas that we can explore in this hackathon, and one is around usability, and one is around just expanding the breadth of applications that we can build. So just like a very standard Secret Networks of blockchain, it's the first public blockchain with privacy preserving smart contracts. So we have contracts that work with encrypted inputs, encrypted state, and encrypted outputs in a public permissionless blockchain. So maybe a bit cheesy, but like Ethereum-like blockchain with encrypted smart contracts. So we are using Cosmos SDK for our consensus mechanism. There is a network-wide consensus in the network. Our smart contracts are based on Cosmos. They're written in Rust and compiled WebAssembly. So you will need to do some Rust coding, but trust us, you don't have to be a Rust expert. There are a bunch of templates to get you started. And the way we have privacy is we're using trusted execution environment. So nodes or validators in the Secret Network runs trusted execution environments, and there is some symmetric key sharing and encryption processes when a user is encrypted their inputs, and then when that gets into the network in an encrypted way. So kind of like very high level and very easy representation of how things work. In the middle, we have this representation, which should look like a blockchain if you can't tell. But users send in encrypted input. So most of you, I guess, are familiar with MetaMask. Imagine like when you're creating an input in MetaMask to be sent to Ethereum. In this case, when you're creating an input to be sent to Secret Network, the inputs are encrypted locally on your device, and only encrypted inputs go into the network. Then the way this encryption works is you encrypt the inputs with your private key and with a public key from the network, and then nodes in this network would share a key can decrypt these inputs inside the enclave of the trusted execution environment, so validators can't technically see this data using the private key of the network and the public key of the user. And that's how the encrypted inputs are being able to processed on within the enclave by the validators, and this information is always stored in the enclave. And what happens is there is an on-chain consensus formed by the validators by forming the hashes. So you start with encrypted inputs. It's decrypted within the enclave, computed, encrypted again. So we have encrypted outputs and we have encrypted state at all times. This helps with things like, because the inputs are encrypted, you never have front running in secret network. So coming to the data economy challenge, what can we build? So we have been in conversation with the Ocean team. We see two interesting things that we can build with data tokens. One is trustless access to data sets. Today, if you buy a data token, you either have to trust the seller of the data token or an operator to give you the data when you give the token to redeem the data, and there's a friction there. So we can make that process frictionless by storing the data or access to the data in a secret contract in secret network. And we have a bridge that I'll talk a bit more about between Ethereum and secret network. So we can use this bridge to move data tokens to secret network, and then allow the contract to show the secret that's stored in its state only to users who own the data token. We have a couple of interesting links for you that you can use to get started. So like the access, like the contract in step 1 is already out there, and there's a bridge that you can use on Robson. And then the second option is around enabling private sets and more sophisticated computations into the data economy. By that I mean we've heard that there are concerns with people sharing more private data sets, and there are concerns with data engineers having their algorithms be public. So what we can do is we can use secret contracts for fully private computations. I just mentioned that secret contracts work with encrypted inputs. So the way a computation like this would work is it would take in both the data, either access through option 1 or just like just data uploaded from a user, both the data and the algorithm as encrypted inputs, and do some run some predefined function with those inputs, like a matrix multiplication and whatnot. And that way, would have the computation fully private, both the encryption, both the algorithm and the data, and we'll be able to have results on which the network reaches consensus. I use this QR code. I also pasted links in the chat, but this takes you to our blog post where we go into these two options in more detail. So again, just going quickly over things that you can build. I think the previous slide really captures, but we have a bridge between Ethereum that allows you to move ERC20s and any Ethereum assets. So would probably move data tokens using this. We'll make data tokens available on our testnets. We're in conversation with the Ocean team at the moment. When you mint a token, you're gonna end up with a privacy token, So like, the wrapped data tokens on the secret network will be these ERC20 like privacy tokens. So if you want to build this like option one, when there's an access control thing, you'd need to, like, by that I mean the secret vaults, you'd need to make that interact with privacy tokens, all of which we'll be very happy to provide help with. Yeah, I think I talked about the bridge. I talked about these the privacy tokens, and then secret vault. I think this is something to spend a minute on, because this is basically the building block for option one that we mentioned. Secret vault allows us to store any signing key or cryptographic information in a contract. In this case, it could be, again, either the data itself or a way to access to an encrypted data set, says hosted on IPFS. What happens is when there's a triggering event, and in this case, the triggering event would be for Alice to send her data token to the contract. The contract would reveal only to Alice the secrets inside it. So that's that. I think at this point I'll take some questions, and there are a bunch of links that could be interesting for you. I'm just gonna share the link to this 1 second to this presentation I just went over, so that may help. But yeah, if you guys have any questions, I think we can take them.
John, great. Thanks for that. And obviously, there's good resources that you guys have put together. So you also dropped that into the chat there, which is very cool. And there's lots of opportunities here that people can get their hands dirty and start to come up with some creative solutions. Personally, what would would you like to see? Do you have any kind of like personal things that you might like to see come out of the Data Economy Challenge with respect to Secret Network? Obviously, you outlined some of them here, but what would you say personally would be the most exciting and maybe Tom also has a view on that as well, but wonder if you guys could share some.
Yeah, Tom, do you want to give it a pass first?
Yeah, why not? Oh, sorry for that. Yeah, so I think in general this topic is very interesting, and I mean, I don't have anything too specific in mind, but I mean, both of the use cases, and particularly, I personally connect more to the second thing, where you like perform a secret or encrypted algorithm in a contract. I think it's an interesting use case. And I think it's interesting to see someone implement or trying to implement something like that. It's not trivial at all, to my opinion.
Right.
So yeah, that's one thing.
Yeah, no, those two use cases obviously help to give some context. Obviously, one is let's say a little more heavy lifting than the other, but both would be very welcomed and obviously fairly doable. Certainly, the first use case would be probably the most easiest to tackle first. But as you said, Tom, it would be exciting to see someone build on that and also take on the second use case. And I think that one should also remember that even though the data economy may end on January 10th, it doesn't necessarily need to end with respect to the integrations between the projects. So this could be the first step, and I think that there's a lot to be done in general to bring the two together. So someone's John, just keep dropping some good good links in the chat there. Everyone, I recommend to take a look at those. Obviously, these will be available following the webinar as well, and that's also good to have in terms of resources. Well, that was really good to have you guys here. Appreciate your time. Appreciate your presentation. Before we switch to the next speaker, I'll give you one last chance to, say some words of wisdom and advice to the participants and to the audience today. Any parting words from your side?
Well, I'm personally very excited about both of the use cases. I think I do think there's a lot of already written code that will help people get started with option one. That I think an ambitious team can do 1 and 2 together, and that would be like that would make me very happy. In terms of parting thoughts, this is the first time that we're participating in a hackathon since we launched secret contracts on mainnet. So this is also a learning experience for us. We're very responsive in our channels, and Sharon, if there's also a channel for the hackathon, would also would want to be active there. And yeah, I think this is exciting, like holiday season, a lot of free time. So we're looking forward to having fun with you and working with all of you.
Yeah, feel free to contact us if you need any help with secret contracts and what else. We're here.
Super. Well, thanks both of you guys, and it would be wonderful maybe if you could drop your presentation into the chat if you haven't done so already. I can't tell by those links, but
I have.
That would be great. So thanks for joining us today. Thanks for supporting the Data Economy Challenge, and thanks for the words of wisdom and the advice and tips you've shared with the community. So appreciate it, and we'll see what comes out at the end of the challenge. So thanks a lot.
Bye-bye.
Very much. Good luck.
Bye-bye, guys.